So the computer science topic for the DCAT this year is tractability, which is great because it's a really interesting topic, and I'll try and explain why in this little sequence of videos. The reason I find it interesting is tractability is the topic really is the limits of computing. We're used to computers getting faster all the time and software getting more powerful, and we can just always seem to do more. But there are some hard limits, and tractability is the study of some of those limits. If you go deep into it, you can come up against topics like the speed of light being a limit, or the number of atoms in the universe, or anything like that. We won't get quite that far, but there are some hard limits which we will explore. The basic topic is about algorithm performance and measurement of that kind of thing. And it really goes into the science and maths of computing, just kind of really digs into how maths can be at the heart of some of what we do. So I'm going to start with an example here, which is the sort of canonical classic tractability problem, which is the traveling salesman problem. And we're going to look particularly at finding a brute force solution to the traveling salesman problem. So let's quickly flick over to Microsoft Paint. So the traveling salesman problem, I don't know, we don't really have traveling salesmen so much these days. Perhaps you could think of it as a courier problem. The idea is that the courier is at home over here, and needs to go to these 4 different places, A, B, C, and D, town alpha, town beta, whatever. And there's different distances between each of these towns. And of course, what the traveling salesman stroke courier wants to do is choose the route which has got the least distance, the most efficient route. And he could go to, it doesn't matter what order he goes to these places, but he just wants to choose the shortest possible route. So, of course, we as humans can look at a map and sort of by eye make a good guess at that, but computers don't have an eye, they need a method. And the method we're going to use here is probably just about the worst method, which is the brute force method, where you look at every possible route and then you pick the best one out of those. It's still relevant though, even though it's a very bad method, because the problems that it highlights, and we'll see that in the maths, is exactly the same no matter what algorithm you use. And we'll see a bit of a sight of that. So let's have a little dive into this problem. The best way to list all of the possible routes you can take is to have a bit of a system. So over here you can see I've listed all the possible routes in terms of, which town you go to and towns you go to in which order. So I've started, you go to A first, then B, then C, then D. So if we do A first, then B, then C, then D. So going to from H to A is 20, and from A to B is 30, and then going from B to C is 90, and from C to D is 45, and then from D to back home is 95. So we can add all of those up, 50, 140, 185, 190, 280 is that route. And we can do exactly the same process for all of these, and which is very simple for a computer to do, and at the end of it just compare and find the lowest value. What you can see as well is I've done a bit of a system here for making sure I've got all possible routes. So this one, these 6 here, I'll go to A first, then B, then C, then D, then A, B, C, D, C, then A, then C, A, then D, and so on. So, you could come up with that system yourself. I think a primary school class would come up with that, no problem at all, given a little bit of time. And then all the B's, that's another 6, then all the C's, that's another 6, and all the D's, that's another 6. So there's 24 routes altogether. Write that there, 24 routes. And of course it is trivial for a modern computer to go through 24 routes and come up with that with this solution, the best solution. So what we're going to explore over the course of the next couple of videos is this was obviously working well for 4 cities, no problems at all. But when we go up, and we don't have to go up very many cities, like 10, 20, 30, 40, and we'll find that the number of routes we have to calculate is going to get out of hand. And that's kind of the whole point of this aspect of tractability. So back to here, In our next video, we're going to do some maths. I'll say it's unnecessary because you're not going to need to do the maths in the DCAT. However, I kind of think that understanding the maths, even if you don't necessarily learn how to reproduce it, and it is quite straightforward maths really, is necessary to sort of be able to explain the concepts of tractability. So that's in our next video.